get started. It's a couple minutes past. Welcome, everybody. Thank you for being here for our first meetup of 2021. It's kind of unbelievable. It's been something like 3.5, almost 4 years now that we've been running timber meetups. So they've evolved and come a long way. And this year, we're going to be doing kind of an interesting intermingling of research-related meetups and sort of like the style we've been doing of late, and kind of closer to a showcase style industry meetup. So keep tuned. They're going to be exciting. For those of you who aren't familiar with who we are, although we see a lot of familiar faces here, we're Tallwood Design Institute. I'm the outreach coordinator. My name is Evan Schmidt. We are a research collaborative between two universities. So that's University of Oregon and Oregon State University. Between those two universities, we were looking at 3 colleges. At University of Oregon, we've got the College of Design. So that is represented by Judith Shine, who's in the meeting with us today. If you want to wave your hand, Judith. She's our Director of Design. At Oregon State University, we're represented by the Colleges of Engineering and the College of Forestry. So our director, Ian McDonald, is also on the call today. We're both headquartered at the A.A. Red Emerson Lab, which is at the College of Forestry at OSU. So we like to emphasize that we have a few sort of core pillars of activities that we engage in, sort of represented by the images we have here on our first slide. On the left, testing and related services. So a lot of our bread and butter work and how we engage with the industry is providing research and testing services. Basically, we have a large sort of and wide net of resources, whether affiliated faculty members in these 3 colleges that I mentioned, or just the research labs that we have access to. So this is a picture of one of the labs we have at the Department of Wood Science. And again, we are headquartered at a larger scale version of this lab at the A.A. Red Emerson Advanced Wood Products Lab. In the middle represents our applied research program. So we conduct peer-reviewed, industry-informed applied research program on a USDA Agricultural Research Service grant. And this research program really is focused on overcoming obstacles to the advancement of mass timber construction, generally speaking, through applied research. So really the goal is to conduct research that overcomes obstacles in the near term that might not otherwise be easily funded. And then finally, education, workforce development is another one of our core pillars. This is a rendering from one of the mass timber design studios that Judith led at U of O. This is representative of a number of the educational services that we provide. One of our latest programs include a mostly online program. That's the Mass Timber Certificate Program. We just are starting to roll out modules on that. We're currently running our introductory course and it's going really well. So if you have interest in that, feel free to reach out to me or Ian. Since this represents a sort of general mass timber seminar series, at least throughout COVID here, I wanted to share a couple other speaker series that you might be interested in. So the first is being put on by our friend and colleague, Greg House from Timber. This is the Mass Timber March Madness, excuse me. It's been going on for about a week now. Ian actually spoke on, I think it was Monday. Is that right, Ian? And we've got something like 32 or 33 more speakers coming throughout the month. It's really interesting. If you follow that link at the bottom, you can learn more about it, and it's pretty affordable. And the second one we wanted to share, we asked if we just shared some information, if we could get people from our meetup group a discount. They agreed. So if you are interested in TimberCon, a similar kind of speaker series, panels focusing on different sort of emerging technologies in mass timber and kind of core issues like climate, sustainability, construction, so on. So I'll share a link for everybody. If you follow that, you can get a discount on the lecture series through TimberCon. So just wanted to share those 2. And with that, I'll get on with the main event. Want to thank both Oliver Lang and Oliver David Krieg for agreeing to come speak with us today. They're going to be sharing a little bit about their company, Intelligent City, and really kind of talking from the angle of their vertical integration, specifically parametric design through fabrication and construction. So I'll let you guys introduce yourselves from here. And thanks again, and looking forward to hearing your talk.
Okay, fantastic. I hope you can hear me.
Yeah.
Yeah, okay, great. OD is sharing the screen. There we go.
Nope, wrong one.
Wrong one.
Sorry for
First
that.
Okay, fantastic. So, OD, why don't you introduce yourself, and then I'll just I'll take the first half of the presentation. OD is going to take the second part.
Yeah, sounds great. So thank you, Evan, Ian, Judith, and everyone involved in inviting us. This is a really great opportunity, and we are really happy to make the connection with the Critical Mass Timber group. My name is Odin Short. I'm the CTO of Intelligent City. My background is I studied architecture in Germany and transitioned relatively early on towards robotics and timber construction and computational design, and worked as a researcher for a couple of years, developing technologies before I joined Intelligent City to assist in the development of the technologies necessary to bring scalable technologies into mass timber urban housing.
Okay, great. So, and I'm Oliver Lang. I'm the co-founder and CEO of Intelligent City. Originally from Germany, came to North America 27 years ago now. Moved to New York to go to grad school at Columbia, and then after some spending time there, I spent about the next sort of 14 years in academia. I have some strange echo in here. Maybe somebody needs to mute. Okay, better, great. Yeah, and after 14 years in academia and sort of a research in urban questions of urban design and cultural design for buildings, and a focus on computational design, becoming ever more interested in design for sort of manufacturing technology. After starting our architecture firm, which we've had for some 20 years now, eventually started Intelligent City with the need to come up with solutions that are more scalable, more repeatable, and essentially more sustainable while addressing some major issues in the urban housing realm that we wanted to focus on. So, could you maybe just advance the slide to the next one? So I want to give you a little bit of an overview of our motivations and how that all leads to I think, our particular way of thinking about what we're building and why mass timber is a great product, and how scalability and design for manufacturing and offsite prefabrication all at the end of the day go hand in hand. So essentially, we believe that there's a far better way for buildings and construction. We're Intelligent City is an urban housing technology company with a focus on highly scalable and adaptable platform. We design and deliver mid to high-rise mass timber buildings as turnkey products, like you see on that background image. We can ultimately save our customers 30 to 50% time and money, and we can provide some additional value add that's very important, like superior quality, affordability overall, and near life cycle carbon neutrality, and do that in perpetuity. That's the ambition of what we're doing. Next. So you know these. I can kind of sort of skip over this a little bit, but just as a sort of a reminder a little bit. So we focus on the housing market, urban housing market, and it's a massive market. It's an $8.8 trillion annual market in the world. We need to build over 1 trillion square feet of urban housing in the next less than 30 years now. And people really and cities demand that we overcome this affordability and housing crisis that we have almost in all successful metropolitan areas in the world, and that we have come up with better solutions. And while we're facing that problem, we're similarly facing the issue that buildings, essentially, when you add in all the key issues and the key metrics, are essentially responsible for almost 40% of GHG emissions. And so stakeholders are now demanding, at least where we are located, that we do better, that we do a lot better, and that we have to come up to a path of carbon neutral building and come up with breakthrough sustainability approaches, not sometime in the future, but really now, and get our buildings ready. And so the industry is really facing two really big problems right now. And yet, as an industry, we're the last laggard. We haven't really seen any significant innovation that help us, and we continue to be slow, expensive, risky, and really just one-off buildings. And then even with what we see in advancement in mass timber and so forth, it's still one-off buildings. It's still custom suits, and strangely, these one-offs still always act as one fits all. They have no inherent adaptability to the changing needs, the varied demographics, all these issues that really we're facing with urban buildings if they really want to be long-term sustainable and allow us to have a thinking about resiliency. So customers are demanding better. Our customers, we're a B2B company. Our customers are building operators, nonprofits, rental market operators, and then sort of boutique green building developers that want to sell a really good product into the marketplace. Next. So in order to address this issue, we've basically come up with a fully integrated solution that we call Platforms for Life. And it's really made out of two main components. One is a product. So we don't look at buildings, as I said, as one-offs, but rather as something that really inherently embeds everything that's important about good urban livability. That you ideally, you can get rid of your car, you can be happy because you have everything in this building that allows you to live meaningfully. And it doesn't matter if you live multi-generationally, you have children or something like this, you don't need the alternative to move out to the suburbs and live within a house, but rather you can embrace the idea of urban density, which is what municipalities really want to make good investments in urban infrastructure and make these buildings viable. So we invest a lot of time and have over the last decade to make sure that this product has everything that's necessary, from good access to daylight, natural cross ventilation, very adaptable homes, that you can really make your home, and the possibility of creating sort of more meaningful communities that are easy to operate long term. All of this sort of minimizing complexity, it's all been built in so that our customers are really happy with that product. It's based on a common platform that's all built out of mass timber. So we embraced that technology about 12 years ago when it wasn't licensed in North America yet, but we realized the power of it, and built a building system around it. And so we had originally started off with our first manufacturing plant to do offsite prefabricated volumetric, but really volumetric modulars, but realized that that's spatially very inefficient, and that we wanted volumetric panels, a panelization process. So what you see here is basically floor panels that are cassette panels at a hollow core, and that we can pre-install certain services in, and that we can modulate for spans that really work well in housing, and essentially also scalable into office and work applications. And it's designed to work in that area of high-rise mass timber specifically. And then we have a secondary system, which are facade panels. They're also mass timber based, and they are designed to be fully passive house certifiable and pre-certifiable, so that we can have a consistent solution that you can erect quickly. You can follow up with those panels, get them get the whole building out of the weather, and then trim out everything else, and all the other things that we don't make are also built into the system and designed specifically for rapid installation and working well with the overall building system. So that's the common building systems platform, and that is married then to an offsite prefabrication and automation process that we're building out right now, so that we can build all these components in a factory using robotics for assembly, placement, nailing, gluing, everything that needs to be done to turn them into the right kind of components. And then lastly, in order for all of these things to work with each other, and to get to this degree of scalability, there is a software engine that basically runs across all of these that allows us to interactively design the buildings so that we can ensure that it will always work with the components and all the stacking rules and everything that you need in a multifamily building, from service integration and so forth, and that it generates the code to do the software code to then translate into the manufacturing process. And Odie will explain that to you a little later in a moment. Okay, next. So as I said, our focus is really, and at 6 stories, we find the economies are starting to work in our favor. Over, we're allowed 6-story wood frame construction right now, but over 5, we start to become competitive. And then we are now in a territory where normally it's concrete buildings, as you know. And then eventually, of course, across the border, when we see more universal adoption of the International Building Code, to be able to go with our system potentially up to 18 stories. Next. So when I talk about scalability, there are 2 things in that matter. And that creates sort of the design space for which we've created the whole system, which is in order to get to replicability in a market that requires variation by nature, because the sites are different, but also the uses are different. Housing cannot be uniform. We all not the same. We demand the possibility for adaptability, and so do our clients, and so do municipalities, which is very different from, let's say, if you build hotels or classrooms or anything that you could basically design, on the basis of a unit or a cell. It's been useful, but for housing, that doesn't work at all. So you need something that's highly adaptable in order to ensure replicability and scalability so that you can get market penetration. So we looked at from the building configurations to the floor plan flexibilities, and this is just a sample of a few homes. We have a whole catalog that goes from really like super compact units to double-story urban sky houses that all work out of the same system, and that needs to be ensured for the approach we believe to be viable. Next. So we have basically, as I said, we have a sort of front-end parametric design software engine that we've been working on for some time that allows us to set the building, fine-tune it, link it to databases about materials, carbon, cost, and the overall performance to it, create a virtual twin model so that we don't really have to figure anything out on site. It's all being done and tested and integrated on the computer, and from there it gets reported out into industry standard BIM models or into machine code for the robotics. So there's 3 main issues that for us where we have our focus, because that's where we ultimately need to get the product to. Our customers find mass timber very sexy, and it's all wonderful, but at the end they really care about affordability, sustainability, and livability, and creating communities, right? And that's what we have to create for. So let me quickly walk you through that and how the system helps with these sort of 3 issues. In this approach, affordability is, in order to get there, we need to get sort of multiple benefits going at the same time, because right now The way how the industry works is really only about what's your dollar per square foot, what's your cost, right? And it's very hard to have any meaningful value discussion. And with Mass Timber, we have the possibility to get to that. So with the product approach and the integration and the focus on this, we can actually get to a home within the same density footprint because of the degree of integration of the components and the services and so forth, which when you do one-off buildings, every single time you get inefficiencies. We can build it much faster and we can drive down dramatically the cost per home. And we can ensure better quality, for better livability, better adaptability, to multiple types, but also future conversion possibly. So the need for buildings to stay flexible so they can be adapted, and then use building science to create better longevity. So that means we have to work off-site. We have to prefabricate to integrate quality control, get the speed advantages. And that, again, that's where the material shines, because from our, we started out looking at prefabrication of steel and concrete, and none of that really was great. But the possibility of used timber, because of its weight, you can handle it in the factory and you can handle it with automation equipment and you can machine it. It had all these advantages. And on top of it, it allows us to sequester carbon and get closer to that paradigm to create a life cycle carbon neutrality for the building. Next. So this relationship between ecology and economy and the use of the material and what it does, that, a 600 square foot 2-bedroom, what this one is here, is not you're not shortchanged. You actually have a beautiful place to live. It gives you everything you need. It's fully integrated. There's no wasted space. And you can enjoy it, and it's very much thinking about adaptability and humanizing the space overall, which we think really matters for the product. Next. And then there's the efficiency I talked about. So we've spent a lot of time looking at that integration of systems and how that works between prefabrication dimension, what you can ship, what people want, natural cross ventilation, access to daylight, flexible floor plans, make even a small home usable for a couple or with a small child and so forth. And how can we change it? And so while going through it, through all these different typologies, we can find meaningful savings in the efficiencies, and that of course brings down your cost to rent an apartment or buy an apartment quite dramatically. So the other issue, when you use an integrated approach where you not just think about the system and the prefabrication at an end of the chain, but you take prefabrication to the beginning, and you therefore the possibility to read out all critical project data at the beginning, you can start to show people not just what it will take and cost to build it, but in fact what it will take cost to operate it. Because at the end of the day, what's interesting about buildings is that essentially you can bring down the discussion very much to a question of geometry and physics, and you can use that in computation and through math and intelligent algorithms to really understand these buildings in a much more complete way and link it to climate data and everything that's necessary to determine this. And of course, there's the cultural dimension, and you want to have people being happy. But we feel we can even go as far in talking about that we can actually bring ideas of computation and quantification to the qualitative, like livability issues and daylight and and everything that sort of makes us comfortable in a building. So the integration of the thinking really leads us to an incredible amount of efficiency gains across the board, because we know from the beginning what the prefabricate component will be like and how it will integrate in the beginning. But the computational power allows us to work through that, even if the buildings vary from site to site. Next. So we don't just design one building, we go through a whole range of them. We make sure that the building stays consistent and then we can help.
I think you cut off there, Oliver.
Next. Okay, so the power of prefabrication is then really that you can find these sort of compounded efficiency gains, while in comparison incumbent buildings, at least in our part of the world, we see consistent cost escalation because of labor shortages and prices in the Pacific Northwest, at least like in Vancouver, keep going up by about 5% a year for construction. And we using data from other industries where automation has been deployed, we cost of doing building for the hard cost and the soft cost. But there's the additional effect of the life cycle cost, where really it matters for our clients just the same, that when you do a building and you can quality control it, and you can extend the life cycle from 40 years to 100 or 120 years by using offsite prefabrication, building science, quality control material like mass timber. You can dramatically decrease the depreciation or increase the value retention in the building, reduce your operating expenses and maintenance cost, and generate data about this. And because what you have to have in mind is with this approach, you give your clients not just another one-off building, you give them eventually a portfolio of buildings so that the parts of maintenance become interchangeable, that the operating software that they use or that we can supply to them, all of that starts to work together. So the idea of creating something that works as a product across multiple buildings is very important, I think, in order to become successful. Next. So then carbon neutrality. Policymakers just demand it increasingly. Next. And we need to be able to supply to that. So we take a very sort of holistic approach in this by looking at the building from natural cross ventilation, passive systems, elimination of cooling and air conditioning, proper orientation, solar shading, and to the use of basically they're full passive house buildings. All our buildings are that. And then the possibility of the carbon sequestration in the building. So when you compare it next, when you compare an incumbent building, concrete building, with a building like we've done about the embodied, the operational, and the behavioral carbon, we could demonstrate that we can get to a carbon reduction of 93% of this. And it is one of the reasons why we were named in Canada winner of the Breakthrough Energy Solutions program here, Breakthrough Energy Solutions Canada. Then Bill Gates, as you know, started the Breakthrough Energy Ventures, and in order to address climate change. And they approached the Canadian government and said, show us your 10 most promising early stage companies in the clean tech world that can demonstrate that through scalability, we can get to a measurable reduction in carbon emissions. And so scalability was sort of the key for us to win this competition, to win this very significant grant for us, and demonstrate through very careful calculation that these buildings, in fact, we can get to that life cycle carbon neutral paradigm sooner than later. And more importantly, that if you don't, as an industry, if we don't, no matter what we do about battery technology and solar and wind and so forth, we can't get to our targets by 2050. We have to do something about the building industry. Next. So obviously, I'm preaching to the already converted here, but I think the possibility I want to highlight right now is this sort of development of a dynamically expanding industry where we, I think, can all work together by focusing on really think about scaling, because if we want to be able to win people over, we have to demonstrate collectively that the gap between the status quo where it is versus what we can do is so significant, the improvements are so significant that it's just no point on keep doing it the way how it was done before. Next. carbon footprint, sorry, not the requested, the embodied carbon footprint, and it's really largely in floor construction and wall construction, and that's why we decided also to focus on that particular part. Next, I gotta go a little faster here, otherwise it will be going on for too long. So we analyze the form factors of our buildings very carefully and look at comparisons, and but also have a lot of surprises in these where we realize that you know, it's not just like in a passive house or any passive house that the cooling loads and heating loads of the buildings are such that if you can deal with natural ventilation in a very good way, then the form factors can be easily mitigated. So the solution is more complex than people think. Often the thought is, let's build passive houses with the most minimal amount of facades and envelopes, but the reality is that that doesn't necessarily get you there. So we optimize the buildings around the issue of form factor, livability, ventilation, and elimination of systems that I wanted to sort of stress. Okay, next. So a couple of quick words of livability, and then I'll let OD take it away. Livability matters tremendously because at the end of the day, no matter what kind of materials we use, what process we use, all of that is actually secondary. If people don't like it, they won't use it. And then they will abandon the buildings, and that's the biggest environmental thing that we could do. So we need to create buildings that people embrace. Next. And that means it has to have sufficient variety, adaptability in it, and it has to give us a path to create integrated communities. Next. We emphasize and as we showed the image before, the qualitative of very, very compact homes matters, and how it relates not just to the home itself, but how it relates to the creation of community. And so when we designed the product, we were always cognizant of the fact that unless we do that, we're ultimately not going to be successful. And our clients really, really like this aspect. They want to create communities. They want to create meaningful product for their tenants. Next. And these kind of features, when you offsite prefabricate and you focus over a product, you can build accessibility, not just in one or another apartment, but you just simply make it a universal rule that all of them are accessible. So small apartment, next, or larger apartment, they all can have these qualitative features if they're built into the palette of what we do. And so can the possibility of common amenities and so forth be built into a product-based approach. Next. So a few lessons learned that got us into what we're doing. So we started out with sort of a one-off building that was beautiful. People loved living in it, but we couldn't repeat it. It was just totally impossible. The industry was incapable. We couldn't find trades. We built community, and that was great. And it worked well, but we couldn't repeat it. So we started out next with the offsite volumetric modular, came up with the whole system, even made it flexible to have them sort of one-sided open, that you don't live just in a box. Next, but found it very spatially intensive to build. It required a lot of manufacturing space. It was slow comparatively. And so, you know, the lessons learned from this was that wasn't the right thing to do. But we did learn a lot of lessons about how you have to think different as a designer when you do offsite prefabrication, logistics, shipping, installation, inspections. You know, what if you conceal something? You have to open things up again. You have to be we learned that you have to be incredibly proactive when you engage in the world of offsite prefabrication. You really have to change your mindset. You can't think that somebody's going to figure it out for you. You have to all figure it out upfront, model it through. And but there were some great things. I mean, this building came together over the course of 36 hours, and you know, was all put together quickly. and rate the qualities and enjoy the the quality control, the integration of details that you would never dare to do otherwise, the flexibility of the space, the accessibility issues. So that was all successful and worked really well. But there were important lessons learned, and one which is my last couple of slides here, is the notion for adaptability. So it has to work across a number of different sites. When we make the argument next that we want to be able to scale into different situations, urban situations, and we want to be as integrated as possible, which we found where we were at the lower left corner, low rise, modular, and we want to go to the top right corner, which was integrated, more adaptable, more scalable. Next. And we want to be able to get in that mid-rise market that we felt was grossly underserved. And where also mass timber can be very viable from a cost perspective, where it competes with low-rise concrete, where concrete is not very efficient. Next. So we made sure that the type works through all these different scenarios, from small infill site to larger development site, from sort of 6 stories all the way to 12 or even 18 stories. Next. So just to reiterate, the system that we've come up with that enables all of this is basically the future vision is that we have CLT shafts included in this. Right now we're using steel cores. We have a spine for the mechanical systems that others make for us. We don't make it ourselves, possibly for prefabricated bathrooms in there that others will make for us. And we focus on the hollow core cassette slab that we make out of components, and then the facade panels we can add. And everything is so designed that you can also accessorize these buildings on the outside with balcony structures that are thermally disconnected from the building. Next. And then have that possible, you can serve that broad range of sizes from small 4 to 6 story buildings that doesn't fall under the higher 7, 10, and 12 story buildings that have under the way right now. And that's really where our focus is. And then the future markets, 11 to potentially even 18 stories. Next. So that's on the urban scale, and then the adaptability needed on the scale of the homes, that we can serve that broad demographic across these urban livability criteria, from daylight, acoustics, privacy, socialization, comfort, choice, adaptability, and so forth, and that it works across these buildings. Right? So we had to make sure that all of that is being bred into the system and verified. So that the consequence of that is then you end up designing from this sort of parametric space for the manufacturing process. So Odi, if you want to take it from there.
Yeah, I think there's maybe a common thread in this presentation that you might have realized, and that is this sort of ongoing discussion, internal discussion in a way, this ongoing challenge of marrying adaptability and flexibility on one side to process in some ways repeatable. And we also think that this challenge, these sort of opposing requirements, might have been the reason why prefabrication and modular construction have never really been taking off in our industry. Many solutions were created in the past that really leverage the possibility of mass production, right? The possibility to hone in on a process and then just repeat it over and over again. But as we all know, that's not the way we want to build buildings. It's not the way we want to live, and that's not what really would be able to penetrate the market. So for us, there is a sort of missing keystone in marrying these opposing requirements, and that is the flexibility of parametric software and automated manufacturing technologies. in combination with our design principles, we are creating basically an ecosystem that is based on a common platform, right? But that platform is not fixed. That platform has a design space. However, we can really only leverage that idea if we really understand how buildings are made. And so that's where DFMA, design for manufacturing and assembly principles, come in. These are concepts that exist, since for these, and it's sort of just, it's telling how architecture, engineering, and construction is sort of discovering that only in recent years. Same with industrial robots, and software technologies. But it really makes you think, because construction has so far been really focused on human capabilities. And if any kind of building part or building component surpasses human capabilities, it's too heavy to lift, it's too big to lift, it immediately went into basically what a crane should be doing, right? And so you have essentially, you've had a gap between the work envelope of a human and the work envelope of a very slow, also pretty manual crane, right? And so simply engaging with technology such as industrial robots and other automation equipment forces you to think about what kind of building elements and what kind of building components can you actually work with, and what kind of processes. It goes much further than just weight and size. What kind of processes can you actually automate? And that's also where the construction industry lags behind tremendously, because many building parts are made for the human hand, for the human dexterity, wood screws, bricks, all these kinds of typical processes when we put buildings together are very much geared towards humans. And so we need to rethink and reinvent some of these building elements and some of these building processes. And so, when you think about the typical manual processes, stick frame, ideal, right? 2x4s, bricks, they're all ideal for humans, versus really, really big elements like huge CLT slabs, which can really just be handled by a gantry car. Building elements and sizes and processes that are really prone to be automated. They're really efficient in automation. And so what we are doing in our development processes when we are looking at prefabricating floor panels and envelope panels is how long can we basically avoid getting into that range where only the gantry crane and the crane on the site can move these panels, and how long can we use robotics and other equipment to manipulate smaller building elements and put them together in different ways. And so that's a huge challenge, because also, admittedly, there are not many processes in place, and so there's a lot of innovation is happening. And so those, what Oliver said, the hollow core floor panels and the envelope panels, that's where sort of that innovation was implemented, which allows us to automate a lot more processes for a lot longer within the factory, until we add manual processes and sort of interface with the typical construction world. So the product-based approach, the common building platform, the physical building platform, and the end-to-end technology, really what they describe is a sequence or an ecosystem of operating systems on on a software or on a digital envelope, if you want. All of these things have to work together. We have to be able to design the buildings within the building system that we have developed, right? So we are basically creating our own game, if you want. We are creating the rules within that platform. We are creating design space. And so we have to be able to explore that design space. We have to be able to work with it so that we design buildings that are buildable with our building systems. And then we have to be able to implement all these building components and building elements. We have to be able to understand what every building part in the building system does, and not only for manufacturing purposes and logistics and so on, but also for the life cycle of the building. And then ultimately, we have to create data manufacturing operations that allow us to basically immediately output all the information required to prefabricate, plan, and construct these buildings. So this is ultimately where parametric or computational design, basic algorithmic design, we think really is the most applicable. You know, it's not a tool to help us design a lobby architecture. It's a tool that supports us in working with this, you know, this pretty elaborate building system that we are developing. It helps us handle that information, and it helps us find optimal solutions as well. And so this is shape and reshape the building. We can add different home types, apartment types, like Oliver said, from our library that we have developed to match, you know, the platform. It automatically puts out all the data. It automatically applies all the building components and building elements, like you see in the floor panels, the wood, and the envelope panel. And so we can iterate through that. Basically, with each design iteration, we get all the data out. So it's sort of an example process here, the way we apply, you can do different distributions, square footage, and so on. Then we move further down the line. All the building elements get automatically populated. You get, you know, an entire bill of materials out of that. You know exactly how many materials by volume, by weight, and so on. You can then move further down and simulate the assembly of the building, coordinate with you know, on-site builders and contractors, and then you move even further down and you create basically the logistics instructions with the robotics. In this case, and the CNC instructions and all of that included. So that's all pretty much connected, really only to enable fast, you know, simple assembly on site to make all that nightmare disappear that you're usually confronted with in a typical one-off construction process. And so now we have stitched together design to manufacturing. And it also means we have all the data that we need to make informed decisions, such as life cycle assessment, the pro forma of the building, the construction cost, the operational cost, the distribution of homes. All these quantities are essentially available up front. And so we can, and that's also a bit of a challenge. We have to sort of filter through the information. We have to develop how we collect the information, how we portray the information, so that we understand the differences in the different design iterations, and we can optimize for certain, you know, for certain values, for certain parameters, such as we optimize for cost, optimize for certain apartment distributions, optimize for embodied carbon, and so on. So this is where things get really interesting, where we have, you know, so much additional data available that we can really really apply some intelligent algorithms that allow us to sort of augment our design process, and they allow us to be more informed about certain options that tell us, you know, the tendency here is towards this shape because of that, or, you know, this distribution of apartment types because of X and Y, and so on. So this is not to automate the entire design process. This is just simply to allow us to focus on what's important and automate everything that's unimportant, right? Automate all the stuff that is, you know, really simple and straightforward, but allow the designer, the architect, to really emphasize quality and design aspects of our buildings. And so this goes all hand in hand. We essentially have to understand the entire prefabrication process. We go, you know, we have gone through different exercises of different facilities, facility layouts. Now that we have our own facility, we are currently implementing already many lessons that we have learned from the last factory, but especially about automation equipment, creating different zones, stations to assemble our componentry. And so this is a bit of a mix of you know, automation has many different requirements than what a typical factory, sort of manually oriented factory looks like. But the main goal here is that the factory itself, in a way, also becomes modular. because the idea about scalability is that we can apply similar concepts, right? I'm saying similar because I don't want to say that the same, because there'll always be some adjustments that are within our design system, within our parametric design. But that sort of we have the modules in our factory at the ready to be implemented in other jurisdictions and other areas, so we can replicate that. We can grow the factories, or just have multiple across the country and North America to serve different market needs. And so that's a back and forth. And it's a super interesting process within the team to talk about manufacturing, building, construction, design, and software at the same time in every this discussion, essentially. But it's extremely important because we have to understand the scope that we are working in, that is happening on site, that is happening, that we are not acting only as the builder, we are not acting only as the architect. We look at the entirety of the project, and as such, we have to coordinate everything that's happening within a very large team. The main goal here is that we create as fast as possible, basically, an enclosed shell, so that the building is airtight and watertight, and well, right, so that we can schedule when our components come in on site, how they get stitched together, and then everything that's happening afterwards. Oliver, you can take over if you want at this point again. There are many barriers to achieving this goal and to scaling within our market.
Yeah, I will try to wrap up soon because I think we're moving here towards the top of the hour quickly.
Yeah.
How much time do I have left? I can wrap it up in a minute or in 5 minutes.
We typically go till
5:30.
So
okay.
I'm getting
so a few. Sorry, I've got an echo again. If there's somebody has a OD, maybe. Okay. I'm on mute again. Great. So I just wanted to share a couple of issues about market barriers that we've experienced, what we can maybe do about them, and then just show you a couple of images of projects we're working on. So, obviously regulation is a big one, and we've taken the approach starting already sort of 7-8 years ago to sit on the table with like chief buildings officials in Canada and talk about what does mass timber high rise really mean, what does it work, where and taking the position that the best is actually just to be part of that conversation and shape that conversation instead of being on the receiving end. There is great risk aversiveness in the industry, of course. So we take and saying, okay, we've got to prove it, right? We've got to test, prove, and certify all the way. So we spent a lot of time writing government grant applications, so we get funding for that, and we've been actually quite successful with that, so that we can go through a rigorous testing and proving program. But also certification is important to build trust. There's a lot of inexperience in the industry, a lot of preconceptions about how to do it and how to do it right. How do you work with builders? How will it all work? And so forth. So we need to lead and educate all the time with this. Procurement, we've figured out, learn is a real problem because as you all know, typical projects work through the design processes all the way to a tendering stage, and by that time it's just too late. Right, so we need to change that, and when we talk with like big housing organizations, it's very slow to change them and basically move towards a more integrated model and going maybe potentially to single source instead of multiple bidders and so forth. But again, we need to show the benefits. Same with the financiers, the lenders. There's a lot of issues in providing money for offsite prefabricated projects. And because, as a manufacturer, you're out of pocket for a long time if you can't do that right. So you have to get it into your contracts with your clients from the beginning that they participate in this part. Create a much better experience for people ultimately, for sure. There's a cultural issues. We're dealing all with the lobbies that fire poison arrows against us all the time, that you've probably all experienced. And then ultimately, we have to show a path that there's a whole new market available for offsite prefabricated high-rise buildings, and get people excited about this. Next. So one of the things that, as I said, we are doing is testing. We have a very rigorous plan that we're starting actually this month. Well, we actually first started on this like a couple of years ago, but it's coming fine to the point that we take our large scale floor panels and we test it, because by the building codes, you're not really supposed to have cavities in mass timber construction. So we're doing all the testing verification that these are sound systems and that they provide credible alternatives, which in Canada is permissible as an alternative solution, and we're going to see how the US regulators will respond to that. We're going through our facade panel system. We're doing a lot of structural tests, and ultimately we're going to relate that all back to the issues of the International Building Code. And the next, you can go to the next image, so that we are ready for that initial 12-story implementation, eventually 18-story adoption in the market in the US and beyond. Next one. So one thing we have done, we had a working group here in British Columbia between the Architecture Institute and the geoscientists and engineers of British Columbia Association got together, and a few of us basically on behalf of these institutes, we wrote a EMTC, or Encapsulated Mass Timber Practice Guide, of all the principles. And I think it's about a 200-page book that's going to be published by the end of this month or early April. And I think it's got a lot of really valuable information in it about how to do it right, and the pitfalls in it all. And so that's sort of part of what we're trying to do, to be a sort of a bit more on the front end and help shape it, because we also had our CBO's office, the building safety standards regulators were also part of this group, and it was a really, really good discussion that we had there. So projects, just to give a couple ones, just a couple of minutes, quickly skipping through here. Next. So we built one that worked out well. Livability was great, and it proved out many of the points that we deeply cared about. Next. And so projects that we got on the go right now are from like 4-story rental. These are from the ground slab up, fully prefabricated through the commercial levels and so forth. We work in strategic alliance with an on-site builder for that. Like all our suppliers are all in a strategic alliance, so we don't tender this. We just go to single source and work with them as partners. And they're developing our shafts, our on-site systems, and because the advantage that we have when you prefabricate and rationalize these buildings is the foundation situations also start to repeat. Your approach to the site starts to repeat, right? You get protocol into this, and that's why you need to have partners, we feel at least. Next. So there's a 6-story building. This is for multi-generational living and shared student residences all at the same time. It's affordable housing, City of Vancouver, from the same system. And then next, here is a project that was a 12-story mass timber building that we've learned tremendous amount from. Unfortunately, our client does not have the funding and had to cancel the whole approach and project. It was too bad, but it certainly, we collectively learned a ton from it. That was called Corvard Landing, a 12-story building. Next. But fortunately, we have a building downtown Vancouver right now that we are delivering after much discussion with the city back and forth. It looks promising, fingers crossed that we can start manufacturing and construction by late summer. This shows a 12-story version of it. We settled with the city to do it as a 9-story, but we're still thrilled with that possibility. And as a last sort of word, bringing it back to sort of a human dimension, these buildings are very rational, and to get to a passive house performance, you just don't want too much going on in the facade in from the beginning was the possibility of sort of like a secondary space, an intermediate space on the outside of these buildings for balconies and solar shadings and vertical gardens and so forth. And when you do that and you separate it, it actually becomes quite cost effective because you don't deal with complexity in the envelope where you deal with water and thermal issues, but rather you have the flexibility, you're liberated again on the outer skin. And that also allows us to vary the appearance of the building, the colors and the patterns, and overall how they fit in the urban landscape. And it brings back a sort of a human scale. So yeah, that's who we are. That's what we're trying to do. I'm very happy to take questions.
Great, thank you guys. We're having some latency and kind of lag issues today, so apologies to everybody for that. Typically, we let people just ask questions directly. It seems like based on how the video is coming through, it might be best just to put them directly into the chat. So if you have questions, just put them there and I'll field them for you. And we have a couple already, so I'm just going to ask you guys and you can respond. We have one from Ben Stinson. How do cores and building shape focused lateral solutions integrate with the modular unit?
Yeah, so they're aligned right now. We're working with on the 6+ stories. We're using prefabricated steel cores that can be erected in conjunction with the modules. And you know, at the beginning there was a discussion. Have to head and so we're much more sympathetic now to the integration of these steel cores. While over the next decade, we're going to develop hopefully solutions where we can use mass timber-based lateral systems.
Okay. And we have one from Alexandra Lee. How do you work with contractors to get accurate bids? Have you found overbidding when the market prices your system?
Yeah, that's an interesting question, but we're not really, you know, as I said, we work in a strategic alliance with our contractors, and the majority of the components that we bring in that really affect us, we source literally from a global supply market, and that really helps us to mitigate the cost of the materials and the componentry, and then we go basically through, you know, preset rates with our on-site contractors, and that's why we choose, you know, right now really predominantly one, maybe two, because at least we have predictability on and clarity on the pricing, and we work with that contractor together on the subtrade supply chain as well, so we get clarity on pricing there. And we prefabricate, you know, systems, everything. We try to have as much prefabricated in the buildings as possible, so that our suppliers also can start to see the benefit of scale.
Got one from Kristen Forward. First, she thanks you for the presentation. And she's asking, are you leveraging any physical material strategies for your components to link them to your data-rich models to help with construction maintenance, end of life, ...
I only got half of the question. Could you repeat it, please?
It's also in the
Sure,
chat.
and I'll paste it in the chat here so you can just read it too. I'll just
Oh, okay. Okay.
So she's asking if you're leveraging any physical material tracking strategies for the component.
Yes. Right. Yeah, absolutely. So that's exactly what our clients are interested in as well. So we try to be able to give our clients at the end, you know, a really predictable as-built models with materials and systems, and stay connected with the clients, right, for the duration of the building.
We got a question from William Silver over at Swinnerton. He mentioned that some of the slides you had earlier on indicated that the construction was 38% faster and 33% less expensive, and he was wondering what the baseline was that those numbers were taken against. Concrete, light wood frame.
It was against concrete and against a comparable 2-bedroom apartment in a building that is about 100,000 square feet.
What is the construction cost per square foot?
Yeah, we don't go by construction cost by square foot, and we don't share that. We go by the cost of a home over its life cycle.
I'm wondering, so I got a question myself, while we wait for more to come in, or we've got one from David Nichols here. What have been the biggest technical or business challenges when bringing this product?
The biggest technical or business challenges when bringing this product system to the automation manufacturing world. Great question. Maybe if I can answer that. I think that slide that showed the difference between manual work and the sort of the robot work envelope and bigger equipment like cranes. That also means that automation equipment that exists might not always be applicable to the construction industry or to prefabrication. So a challenge here is to find the right tools to do the right processes to build components that are that meet the qualitative standards and the standards in housing and building buildings. So you have to sort of invent a little bit on the equipment side. You have to invent a little bit on the processes, and you have to invent a little bit on the products and the materials you're using. And it is obviously it requires capital to purchase these tools and equipments. So what we are also trying to do is we're trying to navigate here between automating everything and doing everything in a traditional way. We have to find some healthy balance and find the most impactful processes to automate to show what these potentials are.
Yeah, I would just add to this that in order to develop something for automation and manufacturing, once you do automation and manufacturing, that's a significant capital commitment that you make. Right? It's not cheap to buy robots, industrial robots. So you really have to spend the time to make sure that your system, at the end of the day, and your approach is viable, that you can deliver on the sort of minimal viable product that can be in the marketplace. And at the end of the day, it's the challenge for all of us all the time to make sure that we get the system right, that the market is interested in this, and that at the end of the day, as a solution, it's viable. And then only, I think, time will tell if we're on the right path or not. We're at the beginning of this journey, but we have spent a decade of investment to go through a first iteration, to build proofs, to set up a set manufacturing, and then sort of carefully hone in the technologies and make them start to talk to each other, right? That's really the thing, to make your building system talk to software, to manufacturing technology, and also provide enough adaptability even within our own organization, so that we still have enough room to learn and improve, right? Because we're certainly, this is a significant undertaking, and we have to stay humble and work with our customers, learn from our industry partners as much as possible, and from people like all of you. I think we need to work this out as an industry and not so much company by company.
I think that's a very important point. We don't want to go in and just sort of push everyone aside. Learning from our customers what they need, learning from the companies and the trades and the contractors and our consultants that we collaborate with. That's important, because ultimately, as much as we are automating in our software and our manufacturing, we have lots of interfaces to the external world, right? You can see that on a software perspective. You can see that we have interfaces to, talk to Revit, to create BIM models that we can submit, to our consultants, and that create plan drawings for permits and all these sort of typical things that happen. And we have interfaces on the construction side because our own components have to be installed on site. And ultimately, the product itself is an interface to the people that live in those buildings and the people that own those buildings. And so it's very important to learn and listen to that, and not, go in as a super big company and just say, this is how everything is being done, and you will listen to us.
I have a question, if I may. Oliver, I'm just curious, you mentioned this building on Granville Street that's this 9-story that you're going to be doing shortly. Is that going to be using a partial iteration of your robotic factory, or will you have things fully online by then? I'm just curious where the manufacturing part of your business is in the, in your evolution as a company.
Yeah, so we have taken possession of our next manufacturing space. We have bought the robots. They are at our integrators in Canada, so they've been shipped over from Europe, and we're commissioning them right now. So it's all very real. They're going to be in Vancouver in about a couple of months, and the entire factory is set up to be able to deliver on these 3 projects. So the Granville project, when it comes together, will come out of our factory and using the process as described.
And that's a first set of equipment, a first phase of automation that we have that will be able to deliver Granville and other projects. But there are, of course, there is many steps in assembling building components, and ultimately there are more building components that we can automate as well. And that sort of depends on how quickly we can grow to have more automation in our factory and to deliver more components as well.
So the first step right now is with the equipment when it's arrived and we have completed commissioning, we create output that will then go into our testing program for the facades and further floor structural testing on the panels, and just to verify. So far we've done the first round of structural tests now, and they have completely outperformed our expectation. It's been fantastic. But there's a lot of things to verify, and as we said, failure delivering these projects not an option, right? I mean, if we, like any project, any of us delivers into the market that creates a disaster, shines a really bad light on the idea of tall wood. So we need to deliver, and it needs to be a success, and we will not do that unless we've completely satisfied ourselves that the systems work, that the manufacturing process work, and that the integration works. Because one thing I think we've seen from a building like Brock Commons, we see it going up, and I at the time it went up, I was the chair of the design panel at UBC, and I was there with some of the officials, and it was just a joy to see the mass timber go up. It was just so fast, so quiet, so clean, so precise. And then the trades came in and they made a mess of it, right? And it caused delays, and the integration just wasn't there. And so for us, it's crystal clear, like the advantage, if we're saying the advantage of mass timber construction is the possibility of prefabrication, it has to include the effort to make sure everything else is integrated with it, and that the systems work not against each other, but with each other, right? So same as the question about, steel cores for seismic, that integration is just as important as the integration of all the mechanical system, plumbing, electrical, fire, sprinklers, and so forth. That all needs to be thought through. And we spent years in developing this platform before we even committed to ordering robots to make sure that we feel at least we're on the right path. We're still working. We still got many thousands of hours left of R&D time to get it to a state of perfect. But we feel now we're at the point where we can manage it sufficiently that we can dare to put one of these buildings up and risk, not risk the money of our clients, but give them a better product.
Got a question on air quality. If you guys have any kind of testing of air quality in terms of finished product, just based on concerns about glue used in mass timber products and passive house standards.
Yeah, that's a that's a very good point. It goes back to the manufacturers of the glue, the discussions, and ensuring that the quality is there. We don't want any bad outcome there. So yeah, just making sure that the products that are used in the panels are meeting our standards.
Yeah, it's I can add to that it's not different from the glue that's used in CLT or plywood. So we're taking care of those aspects.
We've got another question from William. He's asking where you're manufacturing the product, and then if you're shipping it volumetrically as indicated in your early projects, or if you now have a kit of parts. Have you found? And then just one last bit, he was asking if you found shipping volumetrically limits the range of being an effective solution.
Yeah. So we did volumetric modular. Now we're doing modular panels. So they're integrated panels, but they're going to be flat packed on a truck or on a ship. And so it arrives as a kit of parts on site, but more integrated, far more integrated than you would do on normal buildings. We manufacture them in BC, in Delta. Yeah, be happy to ship some into your market.
Yeah, flat packing a building definitely helps in shipping it further as well and keeps the transportation costs low.
If an owner was willing to entertain jumping on their first mass timber project ever, what is your chief way to convince them?
So it's interesting. Yeah, it's a really interesting discussion. We wreck our head around that all day long. So don't take what I say as being the answer, right? It's just lessons learned that I can share. What we learned from the nonprofit sector, for example, where you would assume that they just care about dollars per square foot and build it as cheaply as possible. It's actually not true at all. What they care about is they're going to operate these buildings for 20 or 30 years. They care about the cost of the buildings. So the more you can show them that a prefabricated building that is carefully thought through gives them certainty about the way how it can be installed, how the process will work, and how it can function and how it can operate. And it leaves behind this sort of nightmarish process that you have in the construction industry right now, with all that fragmentation and the delays and the change orders and the adversarial conditions that are there. And you can show them that the idea of offsite prefabrication and mass timber is a way to consistency, predictability, and good long-term operations. We've had now some coming to us and saying, you know what, I'll take that any day over the nightmare that I'm experiencing right now. And if you have people that are in that market. So in a way, I think we find the best kind of clients right now to go to are not the ones that want to build a single buildings and sell it off and run, but are those who actually create buildings all the time. They understand the pain the best. And they can see the advantages of consistency. So we don't sell mass timber buildings. We sell a good process, a good experience, a good product at the end. And mass timber just helps us to get there, right? But we're not going to just sell philosophically that. Yes, we say here's a path towards carbon neutrality, and mass timber again helps. And mass timber is great for prefabrication. And yay, it's nice, right? People find it sexy, and it's a good discussion point.
I might kind of dovetail into that question. I'm wondering if you guys can discuss a little bit more where you're receiving the most pushback. Is it related to the mass timber or the automation? Is it industry lobbies or other professionals kind of at the cultural level, or is it regulation?
Well, nobody wants to be first, right? Everybody likes to be third. And when you have 3 buildings, they like to be 10th. People are just inherently risk averse. Procurement, people that work in organizations, particularly when they relate to government, that do a lot of housing, for example. They're procurement officers, and they only know the typical tendering processes, and they don't understand what it means to bring people on early. So procurement and financing can be an issue, for sure. We found inspectors to be surprisingly open to innovation, and the CBOs, the chief building official offices and so forth. If you go to them on day one and saying, I want to build a building like this, many of them are actually really excited. And we've had that experience already a decade ago and saying, yeah, we're going to build it off-site. Will you be willing to come to our factory? Well, no, but we could do it this way. And, so there's certain things you can overcome with proactiveness for sure. But the world of finance, and procurement issues and contracting is still tough, right? The regulatory thing seems to be immobile, but I think now with the MTC, that has opened just a lot of possibilities for us. So, those were like, I had that slide about the barriers, right? That shows a lot of these issues.
We got any other questions? You guys touched on, I've got one more then. I know you guys touched on it a little bit, but I'm wondering if you could also discuss a little bit more, I guess, the logic behind the computations in terms of the units and their layouts. So are these totally prescribed units that sort of are fitting to a general footprint, and then kind of based on the volume of the structure, you're kind of using different modular units and combining them in a way, or are the units themselves kind of dynamically changing in terms of sort of square footage for different programmatic uses like living space versus kitchen or something like that? I guess I'm wondering how the design element automates the units and how you keep that kind of idealized design, where you guys came up with that.
Yeah,
well,
so, yeah, go ahead, Odi.
Oh, okay. Yes to both. It's basically the design of the units has to come first, right? We have to figure out for a certain size or available space, what is an apartment that is worth living in, and then around that we basically create we call it a design space, which is a theoretical concept. So the apartments can be resized and can fit into a certain minimum and maximum dimensions, right? So we're basically creating a library of different apartments, and they themselves have variations within them that can either be triggered by constraints like dimensions, right? So if we say here should be a 1-bedroom, but then the grid or the module becomes a certain size, maybe then there is room for another storage, or the kitchen can grow, right? So there are constraint-based triggers in a way that implement that automatically. And then there are user-informed decisions that we might want to change. So maybe you actually do not want that storage unit, you just want a bigger living room, right? So you can say that to exclude that again. So basically, if you were to size up the available space, it would automatically populate that space with a 1-bedroom, a 2-bedroom, a 3-bedroom, and so on. But you could then still go in manually and change some of these decisions. So we basically give that design space that makes the most sense, and leave some room to make user decisions based on some preferences or some other input.
But at any given time, it's always ensured that it remains buildable within the system, and with what's at the end what you can ship and what can perform and what can do the structural spans. But every single aspect has been designed with a certain range in mind, right? so that you can optimize to that particular need. So the libraries are not fixed home types that you just rubber stamp in there. They're all built to have adaptability and intelligence in the model.
And I think what maybe hasn't really been shown is that, of course, there are constraints in the entirety of the building, like shaft spaces have to go somewhere, right? So you cannot just simply stack two bedrooms and 3 bedrooms all across the building as you see fit. They have to somehow, the bathrooms have to align somehow in some particular way. And this is all based on the rules that where the shaft spaces can go, how big the shaft spaces are, how much horizontal versus vertical, pipes do you want, and all these things sort of, they give us the rules essentially, right? So we go through this exercise and we try out different things. We ask our consultants what is possible and what isn't, and so we are shaping sort of this set of rules that allows us to then populate the apartment. So you're free to place apartments here and there, but then the system will sort of push you in one direction, or it will tell you that this is not possible, or it can optimize it for you and say, let me reshuffle the building and put the apartments in a certain order so that you have the least shaft spaces.
Yeah. What's important for us to answer your question is that we can right now in the development of the whole technology, we can stress test it so that we can see where it has its limits, where it fails. But at the end, the way at the beginning we just wrote these parametrically, but now we're writing it all in advanced software code so that we can essentially, with increased computational power, deploy ideas of evolutionary algorithms or even AI on these models, so that with ever greater sort of complexity that we're asking about these buildings, about optimal configuration relative to orientation and solar and ventilation issues and heat gains of buildings and usability, that we can get to the point where we can have really fully optimized buildings for the need of that particular customer, for that site and that profile and so forth. So we're just trying to keep the design of these homes that essential qualities are ensured, and then there is a flexibility space built around it so that the unit can also, or the home can work really well within the configuration of the building. But then, an owner comes in saying, I just changed my mind. I have a different rental income statement, or the city came back and said, I don't need 20% 3 bedrooms, I need 40%, right? And so we can literally on the fly change that, and the building gets re-optimized for that particular income model, for example, that they require to make the performer work.
Thank you. Well, that's perfect. That leaves us at 5:30 on the nose. So want to thank both you, Oliver David Krieg, and you, Oliver Lang, for joining us. Really interesting presentations, and leaves a lot of food for thought. So if everybody that's here wants to join in a silent emoji clap of hands. Thank you.
Thank you so much.
Yeah, and we're looking forward to hearing from you guys in the future and seeing some of your projects.
Yeah,
for sure.
Please feel free to, thank you for having us, and please feel to reach out anytime if you have any questions.
Great. Okay. Well, yeah, thank you, everybody. We look forward to seeing you at the next meetup about a month from now. So.
Okay, super. Thank you.
Bye, everybody.
Bye.
Have a good evening. Bye.